Hello there, and welcome to Midnight Science. I'm so glad you found your way here tonight. Maybe you've been gazing at the stars, wondering about worlds beyond our own. Maybe you're simply ready to let go of the day and drift into something vast and distant. Either way, you're exactly where you need to be. Tonight, we're leaving Earth behind. We're traveling across the darkness to visit our neighbor, the red planet Mars. A world of rust-colored deserts, ancient valleys, towering volcanoes, and mysteries that have captivated humanity for centuries. We'll move gently through its landscapes, its history, its secrets, learning about dust storms that blanket hemispheres, polar ice that whispers of water, and rovers that roam its surface like lonely explorers in an endless frontier. Some of what you hear tonight may surprise you. Other facts might simply wash over you like a gentle tide, soothing, curious, and quietly unforgettable. If this peaceful journey through space brings you calm or sparks your imagination, consider liking and subscribing. It helps others find their way here too, one sleepy soul at a time. Also, I'd love to know where you're tuning in from and what time it is there. It's always wonderful to see how these videos bring people together from all around the world. But for now, let yourself settle in, take a deep breath, release whatever weight you've been carrying, and let's begin this slow, soothing voyage to the red world that has haunted our dreams since we first looked up at the night sky. Mars is named after the Roman god of war. Long before telescopes, before spacecraft, before we knew what planets truly were, ancient observers noticed a reddish point of light moving through the stars. Its color reminded them of blood, of battle, of fire. The Romans called it Mars, after their god of war. The Greeks knew it as Ares. The Babylonians called it Nergal, their deity of death and pestilence. This crimson wanderer stood out against the black velvet of night, neither twinkling like a star nor pale like other planets. It glowed with an eerie, steady light that seemed almost alive. No wonder our ancestors saw it as ominous, a celestial warrior watching from above. Today we know the red comes not from anger or blood, but from rust. Iron oxide coating the planet's surface, oxidized over billions of years. But the name remains. A reminder that Mars has always captured our imagination, stirring something primal in the human heart. A day on Mars is almost the same as Earth. If you were standing on the surface of Mars, watching the sun cross the sky, time would feel strangely familiar. A Martian day, called a sol, lasts 24 hours and 39 minutes, just slightly longer than an Earth day. This similarity is one of the reasons Mars feels so accessible in our minds. You could wake with the sunrise, work through the afternoon, and watch the sunset without your internal clock feeling too disrupted. Seasons change, shadows lengthen. The rhythm of day and night continues, almost like home. But there's a gentle slowness to everything on Mars. That extra 39 minutes stretches each day just a bit longer, like a breath held slightly past its natural end. Time moves differently when you're 140 million miles from home, measured in sunrises over alien horizons. Mars has the largest volcano in the solar system, rising from the Martian surface. Like a monument to ancient fire stands Olympus Mons, the largest volcano we've ever discovered. It towers nearly 72,000 feet high, almost 3 times the height of Mount Everest. If you stood at its base, the summit would curve beyond the horizon, too vast to see in a single glance. But what's even more astonishing is its width. Olympus Mons stretches 370 miles across, roughly the size of the entire state of Arizona. It's so massive that if you were climbing it, you might not even realize you were on a mountain at all. The slope is so gentle, rising only about 5 degrees, that it would feel like walking across a vast, tilted plain. This giant formed over millions of years, built layer by layer from lava flows that cooled in the thin Martian air. It hasn't erupted in ages, perhaps tens of millions of years. Now it stands silent, a frozen wave of stone watching over a quiet world. In the stillness of the red desert, Olympus Mons sleeps. The sky on Mars is butterscotch at noon and blue at sunset. We think of Mars as red, and it is, but its sky holds surprises. During the day, when the sun climbs high, the Martian sky glows a yellowish tan, sometimes described as butterscotch or salmon pink. This happens because fine dust particles in the atmosphere scatter light differently than Earth's air does. But at sunset, something magical occurs. As the sun dips toward the horizon, the sky around it turns blue. It's the reverse of Earth, where our sunsets blaze orange and red. On Mars, blue light scatters through the dust, creating a small halo of coolness around the descending sun. Imagine standing on a rocky plain as day fades. The rust-colored ground glows in the fading light. Above you, the butterscotch sky deepens, and there, at the edge of the world, a tiny disk of sun sinks slowly, wrapped in a quiet circle of blue. The colors of Mars are not what we expect, but they are no less beautiful. Alien and gentle, like a dream painted in unexpected hues. Mars has 2 small moons that look like potatoes. Mars doesn't have a large luminous moon like Earth's. Instead, it has 2 tiny companions, Phobos and Phobos. They're irregularly shaped, lumpy and cratered, more like captured asteroids than traditional moons. Phobos, the larger of the 2, is only about 14 miles across. Deimos is even smaller, just 7.5 miles wide. If you stood on Mars and looked up, Phobos would appear much smaller than our moon, only about 1/3 the width in the sky. Deimos would look like a bright star, barely distinguishable from the planets. These moons don't inspire poetry the way Earth's moon does. They don't glow with soft romance or pull tides across oceans, but they have their own charm. Phobos races across the sky, orbiting Mars so quickly that it rises in the west and sets in the east, completing 3 full orbits every Martian day. Deimos drifts slowly, taking more than a day to cross from horizon to horizon. They're strange, misshapen companions, but in the lonely skies of Mars they keep watch, tumbling through space like silent sentinels. Phobos is slowly spiraling into Mars. Nothing lasts forever, not even moons. Phobos, the larger of Mars's 2 companions, is falling. Not quickly, but inevitably. Every century, it drifts about 6 feet closer to the planet. Tidal forces, the same that pull on Earth's oceans, are dragging Phobos inward. In about 50 million years, Phobos will either crash into Mars or, more likely, break apart into a ring. Imagine that, a future Mars surrounded by a glittering band of debris, fragments of a moon that once orbited above. The process will be slow, silent, and beautiful in its own way. For now, Phobos still hangs in the sky, battered and ancient, but its fate is written in the mathematics of gravity. One day, Mars will claim it back, and in that distant future, under skies we'll never see, the red planet will wear a crown of shattered stone. Mars is home to the largest canyon in the solar system, stretching across nearly a quarter of Mars's circumference, lies Valles Marineris, the grandest canyon system ever discovered. It's over 2,500 miles long, as wide as 120 miles in places, and plunges more than 4 miles deep. If you placed it on Earth, it would stretch from New York to California. The Grand Canyon would fit inside it many times over. This isn't just a canyon, it's a scar, a vast wound in the planet's crust. Scientists believe it formed billions of years ago as the Martian crust cooled and cracked, splitting open along lines of weakness. Walking along its rim, you would see cliffs dropping away into shadow, layers of rock exposed like pages in a history book. The walls show stripes of different minerals, evidence of ancient geological processes we're still trying to understand. In some places, landslides have sent entire mountains tumbling into the depths. Valles Marineris is silent now, carved by forces long stilled, but it remains a testament to the violent, patient processes that shape worlds. A canyon so deep you could lose the sky. There's water ice at the Martian poles, at the very top and bottom of Mars, where temperatures plunge and sunlight arrives at a slant. Ice gathers. The polar caps of Mars are made partly of frozen carbon dioxide, dry ice, which comes and goes with the seasons. But beneath that, and mixed within it, lies something more precious: water ice. In the northern polar cap especially, there's a lot of it. Thick layers, perhaps a mile deep in places, holding more water than some of Earth's largest lakes. This ice is ancient, a reservoir that's been sitting quietly for countless ages. If humans ever walk on Mars, this ice will matter. It could be melted for drinking water, split into hydrogen and oxygen for fuel and breathing. It's one of the keys to survival on a world without oceans or rain. But even now, just knowing it's there changes how we see Mars. Not as a completely dead desert, but as a place where water once flowed and still waits, frozen in patience. Mars has seasons just like Earth, because Mars, like Earth, tilts on its axis about 25 degrees. The planet experiences seasons. As it orbits the Sun, different hemispheres lean toward or away from the light, just as ours do. Spring arrives, summer warms the surface, autumn cools, winter freezes. But Martian seasons are longer. A year on Mars lasts 687 Earth days, so each season stretches out, slow and languid. Spring in the northern hemisphere can last over 190 sols. Autumn lingers, winter waits. The seasonal changes are visible even from orbit. In winter, carbon dioxide from the atmosphere freezes out at the poles, expanding the ice caps. In summer, they shrink as the dry ice sublimates back into gas. Dust storms rise with the warmth. Frost patterns appear and vanish. If you lived on Mars, you would watch the world transform slowly around you. The tilt of sunlight would change. Dust devils would dance in the summer heat, and in the deep cold of winter, frost would creep across the stones. The rhythm of seasons would mark time, as it does on every tilted world that turns beneath a distant star. Mars is only about half the size of Earth. Mars is a smaller world than ours. Its diameter is roughly 4,200 miles, just over half of Earth's. If you held them side by side, 2 Mars-sized planets could fit inside Earth with room to spare. This smaller size means less gravity. On Mars, you'd weigh only about 38% of what you do on Earth. A 150-pound person would feel like they weighed just 57 pounds. Jumping would feel effortless. Walking would have a lightness to it, a gentle bounce with every step. But this smaller size also means Mars has less mass. less internal heat, and a weaker magnetic field. It cooled faster than Earth, and its geological engines slowed and stopped billions of years ago. In a way, Mars is like an older sibling, smaller and quieter, shaped by the same cosmic forces, but having aged differently. A world that grew up too fast and then went still. The Martian atmosphere is incredibly thin. When you picture an atmosphere, you might imagine the thick, comforting blanket of air that wraps around Earth. But on Mars, the atmosphere is whisper-thin, less than 1% as dense as ours. Standing on the surface, you'd be in what's essentially a near vacuum. This thin air is mostly carbon dioxide, with traces of nitrogen and argon. There's almost no oxygen. You couldn't breathe it even if it were thicker. And because it's so thin, it offers almost no protection from radiation or micrometeors. The cold of space presses close. The pressure is so low that liquid water can't exist on the surface. If you poured a glass of water onto the Martian ground, it would immediately boil and freeze at the same time, turning to vapor and ice in seconds. This thinness shapes everything on Mars, from the pink sky to the massive dust storms, from the bitter cold to the silence. Sound carries poorly. Winds, though fast, feel gentle. Mars breathes, but only faintly. You could see Earth from Mars as a bright star if you stood on Mars at night, away from the dust and haze, and looked up at the black sky. You could find Earth, not as a disk, but as a point of light, a bright star among many. It would shine steadily, not twinkling, hanging in the constellation Virgo or wherever its orbit had carried it. With a small telescope, you might even see the moon beside it, a fainter companion. From that distance, 140 million miles away, Earth would look delicate, pale blue against the endless dark. All of humanity, every city, every ocean, reduced to a single pixel of light. It's a humbling thought, that from Mars, Earth is just another wandering star. But it's also a reminder of connection, a thread of light stretching across the void, a signal that somewhere out there, home still shines. Mars rotates at nearly the same speed as Earth. The tilt and length of day aren't the only familiar things about Mars. The planet also rotates at almost the same speed as Earth. Its spin creates the same rhythm of daylight and darkness, the same cycle that governs when we wake and when we rest. This similarity makes Mars feel approachable. If you were designing a human settlement, you wouldn't need to adjust to radically different time cycles. Crops could grow under predictable light patterns. Sleep schedules could remain natural. The circadian rhythm that governs life on Earth would still apply, almost unchanged. It's one of many small coincidences that make Mars seem less alien than it is. A neighbor that, despite its cold and silence, shares something fundamental with us. The rhythm of a world turning beneath the sun. Dust storms on Mars can cover the entire planet. Mars is a world of wind and dust, and sometimes that dust rises in storms of unimaginable scale. Most dust storms are local, swirling across a valley or plain before dying out. But every few years, conditions align, and the storms grow. They spread and merge, feeding on each other, until the entire planet is wrapped in a veil of airborne particles. These global dust storms can last for weeks or even months, blocking out the sun and plunging the surface into a dim, eerie twilight. During the storm of 2018, NASA's Opportunity rover, which had been exploring Mars for over 14 years, lost contact. Dust covered its solar panels, The sky darkened. The little rover went silent and never woke again. It was a quiet ending to a long journey, buried not in stone, but in wind. These storms are not violent in the way Earth's hurricanes are. The thin atmosphere means even high-speed winds carry little force, but they're vast, patient, and all-encompassing. The planet breathes out dust, and for a time, Mars becomes invisible even to itself. Mars has ancient riverbeds carved into its surface. When we first sent spacecraft to Mars, we expected a barren, cratered world. What we found instead were valleys, channels, and dried riverbeds winding through the landscape. These features look strikingly similar to rivers on Earth, with branching tributaries, meandering curves, and deltas where they once emptied into larger bodies of water. Some of these channels are enormous, carved by catastrophic floods that may have released millions of cubic meters of water per second. Others are smaller, gentler, suggesting steady streams that flowed for long periods. The evidence is undeniable. Water once ran freely across Mars, but that was billions of years ago. Today, these riverbeds are dry, filled with dust and stone. The water is gone, frozen at the poles or lost to space, yet the memory remains etched into the surface like fossil footprints in ancient mud. Walking through these valleys, you would trace the paths of rivers that died before Earth even had oceans. Mars lost its magnetic field billions of years ago. Earth's magnetic field is like an invisible shield, protecting us from the solar wind, charged particles streaming from the sun. Mars once had a similar shield. Early in its history, its core was hot and molten, generating a magnetic field that wrapped around the planet. But Mars is smaller and it cooled faster. Its core solidified and the magnetic field faded away. Without that protection, the solar wind began stripping away the atmosphere, molecule by molecule, over millions of years. The thick air that once allowed rivers and rain gradually thinned, until only the wisp of atmosphere we see today remained. Some regions of Mars still show traces of ancient magnetism, frozen into rocks like echoes of a lost shield. But the field itself is gone, and with it went the chance for Mars to hold on to its warmth, its water, and its potential for life. It's a quiet tragedy, written in physics, a world that lost its armor and slowly bled into space. The gravity on Mars is much weaker than Earth's. Walking on Mars would feel surreal. With only 38% of Earth's gravity, your body would be light, almost buoyant. Each step would carry you farther than you expect. You could leap higher, bound across rocks, and land gently, like moving through a dream. But this lightness comes with trade-offs. Your muscles, evolved for Earth's stronger pull, would be overqualified. Over time, without resistance, they might weaken. Bones, too, would lose density, as they do in space. Astronauts on Mars would need to exercise daily, fighting against the ease of movement to stay strong. Still, there's something appealing about it. The freedom of lightness, the sensation of gliding rather than trudging. On Mars, you would move differently, think differently about weight and effort. Every action, from climbing a hill to picking up a stone, would be transformed by the gentle pull of a smaller world. Mars has no liquid water on its surface today. The Mars we see today is a desert in the truest sense. There are no rivers, no lakes, no oceans. The atmospheric pressure is too low, and the temperatures too cold for liquid water to survive. If water appears, it either freezes instantly or boils away into vapor. But there are hints, tantalizing clues. that liquid water might still exist beneath the surface. Radar data suggests possible underground reservoirs, briny lakes kept liquid by salts and pressure. And in some places, dark streaks appear on slopes during warmer seasons, fading as temperatures drop. These recurring slope lineae may be caused by salty water seeping from the ground, though the evidence remains debated. If there is liquid water hiding beneath the rust-colored surface, it changes everything. Water means potential. It means chemistry. And where there's water, there's the faint possibility, however remote, that life might find a way. For now, the surface remains dry, but below, in the dark and cold, something may still flow. Temperatures on Mars can vary wildly. Mars is a world of extremes. At the equator, on a summer afternoon, temperatures can climb to a relatively pleasant 70 degrees. For a moment, it almost feels comfortable. But as soon as the sun sets, the thin atmosphere fails to hold any heat. Temperatures plummet, dropping to 100 degrees or colder by morning. At the poles in winter, it gets even more brutal. Temperatures can fall below 200 degrees, cold enough to freeze carbon dioxide out of the air. The ice caps grow, frost spreads. The planet becomes a freezer. This temperature swing, sometimes over 100 degrees in a single day, would be jarring. You'd need shelter, insulation, and careful planning just to survive the night. There's no ocean to moderate the climate, no thick air to hold warmth. Mars heats and cools rapidly, swinging between extremes like a pendulum, never settling into comfort. The Martian year is almost twice as long as Earth's. Because Mars orbits farther from the Sun than Earth, it has a longer path to travel. One complete orbit takes 687 Earth days, or about 1.88 Earth years. If you lived on Mars, you'd celebrate your birthday less than once every 2 Earth years. Seasons stretch out accordingly. A Martian summer might last 5 or 6 Earth months. Spring lingers, winter drags. For someone used to Earth's quick seasonal shifts, Mars would feel slow, like living in a world where time moves at half speed. But there's something peaceful about that. Seasons that last long enough to truly settle in. Changes that unfold gradually, giving you time to adjust, to notice the small shifts in light and temperature. Mars doesn't rush. It turns steadily through its long year, patient and unhurried. Mars has polar ice caps that grow and shrink with the seasons at the north and south poles of Mars. Ice accumulates in thick caps that gleam white against the red surface. These caps are made of water ice and frozen carbon dioxide, layered over countless seasons. As winter approaches, temperatures drop low enough for carbon dioxide in the atmosphere to freeze. This dry ice settles onto the poles, expanding the caps. In some years, the southern cap can grow to nearly 250 miles across. Then, as spring returns and temperatures rise, the dry ice sublimates, turning directly from solid to gas without melting. The caps shrink, retreating to their permanent cores of water ice. This seasonal breathing is visible even from Earth through telescopes. Ancient astronomers noticed it centuries ago, watching the white patches at Mars's poles wax and wane. It's a rhythm, a sign that Mars is not static, but alive in its own slow way, exhaling ice in winter, inhaling it back in summer, a planet breathing through the cold. Olympus Mons is a shield volcano. The towering Olympus Mons is not a steep, explosive volcano like Mount St. Helens or Vesuvius. It's a shield volcano, built from countless gentle lava flows that spread outward in thin sheets, Over millions of years, layer after layer accumulated, building height and breadth. Shield volcanoes form when lava is relatively fluid, flowing easily across the surface before cooling. On Earth, the Hawaiian Islands are shield volcanoes. But Earth's tectonic plates move, carrying volcanoes away from their magma sources. On Mars, there are no plate tectonics. A volcano can sit over the same hotspot for eons, growing larger and larger without interruption. Olympus Mons is the result, a mountain built over unimaginable time, each lava flow a whisper of ancient heat. Now it's silent, frozen in place, a monument to the geologic patience of a world that has long since cooled. You would see 2 sunrises and sunsets from Phobos every day. If you stood on Phobos, the larger of Mars's moons, the sky would be a strange and dizzying place. Phobos orbits so close to Mars, just 3,700 miles above the surface, and moves so quickly that it completes an orbit in only 7 hours and 39 minutes. From the surface of Mars, this means Phobos rises in the west and sets in the east, the opposite of Earth's moon. And because it orbits 3 times per Martian day, you'd see it rise and set 3 times in a single sol. But from Phobos itself, looking down, Mars would loom enormous, filling half the sky. And because Phobos is tidally locked, always showing the same face to Mars, the planet wouldn't move across the sky. It would just hang there, massive and red, slowly rotating as you orbited. Twice a day, you'd watch the sun rise over Mars's curved horizon and set behind it again. A cosmic dance, fast and strange, seen from a tiny rock hurtling through space. Mars once had a thicker atmosphere billions of years ago. Mars was a very different world. Its atmosphere was thicker, perhaps similar to Earth's in pressure, made mostly of carbon dioxide with traces of other gases. This denser air could hold heat, creating a greenhouse effect that kept the planet warmer than it is today. Under that thicker sky, water could flow. Rivers carved valleys, lakes filled craters. Rain may have fallen soft and steady over landscapes that are now frozen and dry. It's even possible that an ocean covered much of the northern lowlands, a vast body of water stretching across a third of the planet. But without a magnetic field to protect it, the atmosphere slowly eroded. The solar wind stripped it away, atom by atom. Over hundreds of millions of years, the thick blanket thinned to a veil. The warmth faded, the water froze or escaped, and Mars became the cold desert we know today. A world that once breathed deeply now whispers. The sunsets on Mars last longer than on Earth. Because of the way dust scatters light in the Martian atmosphere, sunsets unfold more slowly. The sun sinks toward the horizon, and as it does, the blue glow around it spreads and lingers. The sky shifts through shades of pink, tan, and finally deep purple as darkness settles. This isn't a flash of color like Earth's dramatic sunsets, painted in reds and oranges. It's gentler, subtler, a gradual transition from day to night. The thin air and fine dust create a softness to the light, a haze that smooths the edges of shadows and colors. If you watched a Martian sunset, you might find it strangely calming. Not the fiery spectacle of an Earth sunset, but something quieter. The sky cooling like embers fading. A slow goodbye to the sun, patient and unhurried, as Mars turns its face away from the light. Mars has the tallest cliff in the solar system at the edge of Olympus Mons. Where the volcano slopes finally end, the ground doesn't gradually flatten, it drops. The escarpment surrounding Olympus Mons is a cliff face that plunges nearly 5 miles straight down in places. is the tallest cliff known in the solar system. Standing at the top, you'd look out over a drop so vast it curves away beyond sight. The base would be hidden in haze or shadow, impossibly far below. Falling from such a height, even in Mars's weak gravity, would take minutes, and the silence would be absolute. This cliff formed as the weight of the massive volcano pressed down on the surrounding crust, causing it to fracture and collapse. It's a boundary, a sudden edge where the mountain simply ends. In the vastness of Mars, it's a reminder that even the largest features can have sharp, dramatic limits. Martian soil contains perchlorids. When landers and rovers analyzed the Martian soil, they found something unexpected. Perchlorids, chemical compounds containing chlorine and oxygen. These salts are scattered throughout the dirt, mixed into the dust that covers the planet. Perchlorids are useful. They lower the freezing point of water, which means briny, salty water could stay liquid at temperatures that would normally freeze it. This might explain those mysterious dark streaks on slopes, and it raises the possibility of underground liquid water. But perchlorids are also toxic to humans. Ingesting them can disrupt thyroid function and cause other health problems. Any future colonists would need to process Martian soil carefully, washing out the perchlorids before using it to grow food or extract water. Mars offers resources, but with conditions. The soil itself is a challenge wrapped in potential. The first successful Mars landing was in 1976. For years, missions to Mars failed. Probes crashed, lost signal, or simply vanished. But on July 20th, 1976, NASA's Viking 1 lander touched down successfully in a region called Chryse Planitia. For the first time, humanity had a functioning robot on the surface of another planet. Viking 1 sent back the first clear images from the ground. Grainy photos of a rocky, desolate plain stretching to the horizon. The sky was pink. Rocks lay scattered everywhere. It was alien, but also strangely familiar, like a desert on Earth under a strange sky. Viking 1 operated for over 6 years, taking photos, analyzing soil, and searching for signs of life. Its companion, Viking 2, landed a month later in a different region. Together, they showed us Mars up close for the first time. And in those images, we began to see not just a planet, but a place, a world with its own character, its own story. Mars has avalanches, yes, avalanches. In the springtime near the Martian North Pole, as temperatures rise and frozen carbon dioxide begins to sublimate, the edges of cliffs can destabilize. Suddenly, without warning, huge chunks of ice and rock break free and tumble down in massive cascades. NASA's Mars Reconnaissance Orbiter has captured these events as they happen. Clouds of dust billowing up as material crashes down slopes. Some of these avalanches are enormous, sending debris hundreds of feet down the cliff face. It's a reminder that Mars is not completely still. Beneath the silence, forces are still at work. Ice expands and contracts with temperature. Slopes become unstable, and occasionally the planet shifts, shrugs, and lets something fall. Even in its quietness, Mars moves. The largest impact crater on Mars is over 6,000 miles across. In the northern hemisphere of Mars lies a feature so vast it's hard to grasp. The Borealis Basin, also called the North Polar Basin, is an enormous depression that covers roughly 40% of the planet's surface. It's over 6,000 miles across and several miles deep. Some scientists believe this basin was created by a massive impact early in Mars's history. a collision with an object the size of Pluto. If true, it would be one of the largest impact events in the solar system's history, a blow so powerful it reshaped the entire planet. The impact may have stripped away much of the northern crust, leaving the lowlands we see today. It might have triggered volcanic activity, altered the climate, and even contributed to the loss of Mars's magnetic field. One violent moment billions of years ago that changed everything. Martian gravity would make everything feel lighter. Carrying equipment on Mars would be easier than on Earth. A 100-pound backpack would feel like just 38 pounds. You could lift and move objects that would be far too heavy at home. Construction, exploration, and daily tasks would all become less physically demanding in one sense. But this lightness brings challenges. Tools designed for Earth gravity might behave unpredictably. Hammers would swing differently. Wrenches would require less force but more control. And after months in low gravity, astronauts returning to Earth would struggle. Their muscles, adapted to the easier environment, would feel the full crushing weight of home. Still, there's a certain poetry to it. Moving across Mars would feel graceful, effortless, almost floating. In a harsh environment where survival is difficult, the planet at least offers this small mercy. You would be lighter, freer, unburdened by the full weight of the world. Mars has clouds. Yes, clouds. Thin, wispy, and high in the atmosphere, but clouds nonetheless. Made mostly of water ice, they drift across the Martian sky, especially near the poles and in the early morning. Some are low and patchy. Others stretch for hundreds of miles, feathery streaks against the pink-tan sky. There are also clouds of carbon dioxide ice, which form at extremely high altitudes and in the coldest regions. These dry ice clouds are rare and beautiful, glittering faintly in the sunlight. From the surface, these clouds would look delicate, almost transparent. They wouldn't bring rain or thunder. They wouldn't shade you from the sun. But they're there, proof that Mars has weather, that its thin atmosphere still moves and changes. Even on a desert world, the sky is never completely empty. Mars may have had life billions of years ago. This is one of the great questions driving Mars exploration. Did life ever arise there? Billions of years ago, when Mars was warmer and wetter, it had many of the conditions necessary for life as we know it. Liquid water, organic molecules, energy from the sun, and chemical reactions. Some regions, like ancient lakebeds, would have been ideal environments for microbial life. And if life did begin, it might have left traces, fossils, chemical signatures, patterns in the rock. So far, we haven't found definitive proof, but we've found tantalizing hints. Organic molecules in Martian rocks, seasonal changes in methane levels that could indicate biological activity or geological processes, ancient environments that look remarkably similar to places on Earth where life thrives. The question remains open, and until we can bring samples back to Earth and study them in detail, or until we land in just the right place and find something undeniable, Mars will keep its secrets. A world that might once have lived, silent now, but holding on to the possibility that we are not alone. The Curiosity rover is still exploring Mars. Since August 2012, a car-sized rover named Curiosity has been slowly rolling across a region called Gale Crater. Its mission was originally planned for 2 years, but more than a decade later, it's still going, still climbing, still sending back data. Curiosity has drilled into rocks, analyzed soil, measured radiation, and taken thousands of photos. It's found evidence that Gale Crater once held a lake, a body of water that persisted for millions of years. It's detected organic molecules and studied layers of sediment that tell the story of Mars's changing climate. The rover moves slowly, carefully, sometimes only a few meters per day. It's alone, millions of miles from Earth, navigating a landscape no human has ever touched. But it keeps going, patient, tireless, and curious. In its solitary journey, there's something deeply moving. A machine exploring a world on our behalf, driven by our desire to know. Mars has morning frost. On cold Martian mornings, especially in the winter and near the poles, frost appears. It settles onto rocks, coats the soil, and glistens faintly in the early light. This isn't water frost, but frozen carbon dioxide dry ice. As the sun rises and temperatures climb, the frost sublimates, vanishing directly into gas without melting. Within hours, it's gone, leaving the surface dry again. But for those brief moments, Mars looks softer, gentler, touched by something almost delicate. Rovers have captured images of this frost, fields of white spreading across red soil. It's a fleeting beauty, a temporary transformation that happens every day in some part of Mars. A reminder that even in the coldest, driest desert, moisture still moves, freezing and thawing in an ancient rhythm. Terraforming Mars is theoretically possible. For decades, scientists and science fiction writers have imagined transforming Mars into a more Earth-like world, a process called terraforming. The idea is to thicken the atmosphere, raise temperatures, and create conditions where liquid water could exist, and perhaps even plants could grow. Some proposals involve releasing greenhouse gases to warm the planet. Others suggest using massive mirrors in space to reflect sunlight onto the poles, melting the ice and releasing trapped carbon dioxide. Still others imagine engineered microbes that could process Martian soil and produce oxygen, slowly building up a breathable atmosphere over centuries. It's all theoretical, of course. The challenges are immense. Mars has lost much of its atmosphere to space, and without a magnetic field, any new atmosphere might be stripped away again. The energy required would be staggering, and the ethical questions are profound. Should we alter another world, even one that appears lifeless? But the possibility remains, a distant dream, that one day, perhaps centuries from now, Mars might bloom, that the red deserts could slowly green, that a world long dead might be given a second chance at life, shaped by the hands of beings from a neighboring planet who once looked up and wondered. Mars has recurring slope lineae. These mysterious dark streaks appear on steep slopes during warm seasons and fade when temperatures drop. They were first spotted in high-resolution images from orbit, thin lines flowing down crater walls and canyon sides. For years, scientists debated what caused them. The most intriguing theory was that they're formed by briny water seeping from underground, flowing briefly in the warmth before freezing or evaporating. If true, it would mean liquid water exists on Mars's surface, at least temporarily. More recent research suggests they might be caused by flowing sand or dust rather than water. But the mystery isn't fully solved. These features still appear and disappear with the seasons, dark fingers reaching down slopes, hinting at processes we don't yet fully understand. Whether water or sand, they're evidence that Mars is active, that its surface changes, responds to temperature, and moves in ways both subtle and beautiful. The planet breathes, shifts, and leaves marks in the dust. The Perseverance rover is collecting samples for Earth return. Right now, as you rest and listen, a rover named Perseverance is working in Jezero Crater, a site that once held a lake and river delta. Its mission is special. It's collecting carefully selected rock and soil samples and sealing them in tubes. These tubes are being left in specific locations on the Martian surface. In the future, another mission will launch to Mars, land, collect these tubes, and bring them back to Earth. It will be the first time we've retrieved samples from another planet. Those samples could answer fundamental questions. Did life ever exist on Mars? What is the planet made of? How did its climate change over time? Sometimes the most important discoveries require patience, collecting evidence now that won't be fully studied for years. Perseverance works alone, drilling, analyzing, photographing, and carefully storing pieces of Mars. It's building a collection, a library of stone that will one day make the journey home. And in those rocks, we might finally find answers to questions we've been asking since we first looked up at the red light in the night sky. Mars has channels carved by catastrophic floods. Among the ancient riverbeds are features that tell a more violent story. Huge channels, hundreds of miles long and miles wide, gouge deep into the crust. These weren't carved by gentle streams. They were torn open by catastrophic floods, massive outbursts of water released suddenly from underground. Scientists believe these floods occurred when subsurface ice melted, perhaps due to volcanic heat or asteroid impacts. The water would have burst through the surface and rushed across the land with tremendous force, carrying boulders, carving canyons, and reshaping the landscape in days or weeks. Some of these channels empty into the northern lowlands, suggesting they may have fed a temporary ocean. After the flood subsided, the water would have frozen or evaporated, leaving behind only the scars of its passage. These features speak to a dynamic past, a Mars that could unleash tremendous energy, where water didn't just flow, but exploded across the surface. A world of extremes, violent and beautiful, now silent. The Martian surface is covered in iron oxide. The red color that defines Mars comes from iron, specifically iron oxide, rust. Over billions of years, iron in the Martian rocks reacted with oxygen in the atmosphere and water, forming reddish minerals that now coat much of the surface. This rust isn't just a thin layer. It's mixed throughout the soil and dust, giving Mars its distinctive hue from pole to pole. When dust storms lift particles into the atmosphere, the sky itself takes on that rusty tone. On Earth, rust usually indicates the presence of water and oxygen. On Mars, it's a record of ancient chemistry, a time when conditions were very different. The planet is essentially oxidized, its iron given to the air, a slow transformation written in color. In a way, Mars wears its history on the surface. Every grain of dust, every rock, carries the memory of reactions that happened eons ago. A world painted in rust, beautiful and melancholy. You would weigh much less on Mars. If you stepped onto a scale on Mars, you'd see a number far lower than on Earth. A person who weighs 180 pounds on Earth would weigh just 68 pounds on Mars. Children would feel like they could fly. Objects would be easy to lift. But this isn't because you've changed. It's because Mars has less mass, and therefore less gravitational pull. The physics are simple, but the experience would be profound. Every movement would feel different. Climbing stairs would be effortless. carrying heavy loads would become manageable. But you'd also need to relearn how to move, how to gauge force and momentum. Drop something and it would fall more slowly. Throw something and it would travel farther. In this lighter world, your body would be freed from some of Earth's constraints, but you'd also be reminded with every step that you're not home, that this is a different world with different rules, written in gravity and dust. Mars once had plate tectonics. Earth's surface is divided into huge plates that slowly drift, colliding and separating, building mountains and opening oceans. For a long time, scientists thought Mars never had this process, but recent evidence suggests that early in its history, Mars might have had plate tectonics too. Some regions show features that look like subduction zones, where one plate slides beneath another. Other areas have patterns consistent with spreading ridges. If Mars did have plate tectonics, it would have been much more geologically active than we thought. But unlike Earth, where plate tectonics continues today, Mars's system shut down billions of years ago. The planet cooled, the crust thickened and locked in place, and the dynamic surface processes stopped, leaving behind only hints of what once was. It's another way Mars mirrors Earth, but only in the past. A world that once moved, shifted, and renewed itself, now frozen in geological time. The Ingenuity helicopter flew on Mars. On April 19, 2021, a small helicopter named Ingenuity lifted off from the Martian surface. For the first time in history, a powered aircraft flew on another planet. It hovered for about 40 seconds, 3 meters above the ground, then landed safely. Flying on Mars is incredibly difficult. The atmosphere is so thin that Ingenuity's blades had to spin at 2,400 revolutions per minute, about 5 times faster than a helicopter on Earth, just to generate enough lift. But it worked, and Ingenuity kept flying, completing dozens of flights, scouting terrain for the Perseverance rover, and proving that aerial exploration of Mars is possible. It drifted over dunes and rocks, captured images from above, and opened a new chapter in planetary exploration. In the thin air of an alien world, a small machine took flight, and for a few precious seconds at a time, it danced above the rust-colored ground, light and free. Mars has no global magnetic field, but some areas are magnetic. While Mars lost its global magnetic field billions of years ago, some regions still retain magnetism, frozen into the rocks like fossilized memories. These are concentrated in the southern highlands, in some of the oldest crust on the planet. When these rocks formed, Mars still had a magnetic field. Iron minerals in the molten rock aligned with that field, and when the rock cooled, the alignment was locked in place. Now, even though the global field is gone, these rocks carry traces of it, small pockets of magnetism scattered across the surface. These magnetic anomalies affect the local environment, deflecting solar wind particles and creating miniature protective zones. They're also valuable to scientists, offering clues about Mars's ancient magnetic field and how it disappeared. In these quiet patches of magnetism, Mars remembers what it once was, a world protected, wrapped in an invisible shield that has long since faded. Martian dust devils are common. On warm days, when the sun heats the ground and creates rising columns of air, dust devils form. These spinning vortices of wind and dust are common on Mars, much more so than on Earth. They dance across the plains, twisting and turning, sometimes growing hundreds of feet tall. From the ground, They would look like ghostly columns, tan against the pink sky, moving with eerie grace. They're not dangerous. The winds aren't strong enough to harm equipment or people, but they're mesmerizing. Rovers have captured images and even driven through dust devils, measuring their properties. Some are so large they can be seen from orbit, dark trails marking their paths across the surface. These whirlwinds are Mars in motion, visible proof that the thin atmosphere still moves, still dances. In the stillness of the red desert, dust devils are moments of unexpected life, spirals of motion in an otherwise quiet world. Mars has layers of ice and dust at its poles. If you could slice through one of Mars's polar caps like a cake, you'd see layers, alternating bands of ice and dust stacked one atop another, each representing a different period in Mars's climate history. These layers formed over millions of years as Mars's axial tilt wobbled and changed. When the tilt was greater, the poles received more sunlight and ice sublimated, leaving behind dust. When the tilt decreased, ice accumulated again. This cycle repeated, building up layers like tree rings. By studying these layers, scientists can read Mars's climate history, understanding how its weather patterns changed over time. It's a geological record written in ice and dust, telling stories of ancient summers and winters stretching back eons. In the polar regions, Mars keeps a diary, and buried in those frozen pages are secrets about how planets change, how atmospheres evolve, and how worlds age. Mars is moving away from the Sun, very slowly. All the planet's orbits shift slightly over time, influenced by the gravity of other planets and subtle effects we're still studying. Mars's orbit, like Earth's, isn't perfectly circular. It's slightly elliptical. And that ellipse gradually changes shape over thousands and millions of years. Currently, Mars is in a phase where its average distance from the Sun is very slowly increasing. We're talking about incredibly small changes, not enough to notice in a human lifetime or even many lifetimes. But over geological timescales, these shifts matter. They affect how much sunlight Mars receives, which influences its climate, the extent of its ice caps, and the behavior of its atmosphere. In the deep past, when Mars was closer to the Sun, or when its orbit was more elliptical, the planet may have been warmer, with more active weather. Orbits are not fixed. They drift, wobble, and evolve. And as Mars slowly moves through space, it continues its eternal dance around the Sun, patient and inevitable. The Martian sky would feel alien and familiar at once. If you stood on Mars and looked up, you'd recognize what you see as a sky. But everything about it would feel slightly wrong. The color, the size of the Sun, the speed at which the moons move, even the quality of the light. The Sun would appear about 2/3 the size it does on Earth, smaller and more distant. It would give less warmth, less light. The sky's butterscotch hue would take getting used to. Neither the blue you've known all your life nor completely unrecognizable. At night, stars would shine brilliantly in the thin, dry air, barely any atmosphere to blur them. You might see Earth as a bright point, Venus as another. The Milky Way would arc overhead, clear and stunning. It's a sky that would remind you constantly that you're not home. But it would also be beautiful in its own way. Alien, yes, but still a sky. Still something you could look up at and wonder beneath. Mars might have underground caves. Scattered across Mars are features called pit craters, circular holes where the ground has collapsed into voids below. Some of these might be entrances to extensive cave systems, tunnels carved by ancient lava flows, or other geological processes. Caves would be incredibly valuable for future explorers. They offer natural shelter from radiation, protection from temperature extremes, and stable environments that don't experience the wild swings of the surface. Some might even contain ice or be warm enough for liquid water. From orbit, we can see these openings, dark spots against the red surface, but we don't know how deep they go or what lies within. Sending a rover into one would be risky, but the scientific rewards could be enormous. Perhaps one day humans will descend into a Martian cave, leaving the harsh surface behind and discovering a hidden world. In the darkness beneath the rust, Mars might hold its deepest secrets. Mars's orbit brings it closer to Earth every 2 years. Mars and Earth orbit the Sun at different speeds. Earth completes its orbit in about 365 days, while Mars takes 687 days. This means that every 26 months or so, Earth catches up to Mars, and the two planets align on the same side of the Sun. This alignment is called opposition, and it's when Mars appears brightest in Earth's sky. The distance between the two worlds shrinks to only about 35 million miles at the closest approaches. This is the best time to launch missions to Mars, when the journey is shortest. But not all oppositions are equal, because both orbits are elliptical. Sometimes Mars and Earth are closer than at other times. The closest approaches happen every 15 to 17 years and are called perihelic oppositions. Even in the vastness of space, there's a rhythm, a cosmic dance where Earth and Mars draw close, then drift apart, only to approach again. Two neighbors in the dark, periodically reaching across the void. The red planet has inspired countless stories. Before we ever sent a probe to Mars, before we knew what it really looked like, humans told stories about it. In the late 1800s, astronomer Percival Lowell claimed to see canals on Mars, straight lines he believed were built by an advanced civilization struggling to irrigate a dying world. Though the canals were optical illusions, the idea captured imaginations. H.G. Wells wrote The War of the Worlds, imagining Martians invading Earth. Edgar Rice Burroughs created John Carter, a hero transplanted to Mars's exotic landscapes. Ray Bradbury penned The Martian Chronicles, haunting tales of human colonization and loss. Mars became a canvas for our dreams and fears, a place where we projected our hopes for other worlds and our anxieties about our own. Even now, as rovers send back real images and real data, Mars continues to inspire, not because it's a fantasy, but because it's real and yet still mysterious. The red light in the sky has always been more than a planet. It's been a question, an invitation, a destination waiting at the edge of imagination. Someday, humans might walk on Mars. This isn't science fiction anymore. Space agencies around the world are planning crewed missions to Mars. The challenges are immense. The journey alone would take 6 to 9 months each way. Astronauts would face radiation, isolation, and the psychological strain of being farther from Earth than anyone has ever been. Once there, they'd need to survive on a world with no breathable air, extreme temperatures, and toxic soil. Every resource would need to be carefully managed, every risk calculated. It would be the most ambitious journey in human history. But it's not impossible. The technology is being developed. Rovers are scouting locations. Engineers are designing habitats, life support systems, and ways to produce fuel and water from Martian resources. One day, perhaps in your lifetime, a human being will step onto the red surface. They'll look around at the rust-colored rocks and pink sky, plant a flag or leave a footprint, and in that moment, Mars will no longer be just a place we study from afar. It will be a place we've touched, a world we've walked upon. And maybe, just maybe, it will become a second home. The silence of Mars would be profound. Sound travels through air by creating pressure waves. On Earth, with our thick atmosphere, sound carries well. But on Mars, with its extremely thin air, sound would behave very differently. Voices would sound muted, quieter, as if you were speaking through cloth. High-pitched sounds would barely travel at all, absorbed quickly by the thin atmosphere. Only low frequencies would carry any distance. The silence would be almost total. No wind howling, even when dust devils spin. No distant sounds traveling from over hills. Just quiet, broken occasionally by the crunch of boots on soil or the hum of equipment. For someone used to Earth's constant ambient noise, the soundscape of cars, birds, wind through trees, Mars would feel eerily empty. It's another reminder of how alien the planet is, not just to the eye, but to every sense. In that profound silence, you'd hear your own breath inside your helmet, your heartbeat, and perhaps, in that quiet, you'd feel more present, more aware of your own existence in a place so far from everything you've known. Mars might help us understand Earth better. Studying Mars isn't just about satisfying curiosity. It helps us understand our own planet. Mars is like Earth in many ways, similar size, similar day length, seasons, polar ice caps, but it evolved differently. Understanding why Mars lost its atmosphere while Earth kept it, why Mars dried up while Earth stayed wet, helps us understand the delicate factors that make a planet habitable. It's a lesson in planetary science, showing what can go wrong, or simply go differently. Mars is also a laboratory for studying climate change. We can watch how carbon dioxide ice affects the atmosphere, how dust alters temperature, how a planet's tilt influences its seasons over millions of years. These insights help us model Earth's own climate systems. In learning about Mars's past, we learn about Earth's possible futures. And in studying how a planet can lose its habitability, we're reminded how precious and fragile our own world is. Mars is not just a destination, it's a teacher, offering lessons written in rust and ice. The dream of Mars endures. For all the facts, all the data, all the images from rovers and orbiters, Mars remains something more. It's a destination not just for spacecraft, but for human aspiration. It represents what we can achieve when we reach beyond what we know. Every mission to Mars is a triumph of engineering, science, and human persistence. Every successful landing, every new discovery, is a reminder that we're capable of extraordinary things. That curiosity can carry us across millions of miles of emptiness. Mars waits, patient, silent, and red. It holds questions we haven't yet asked and answers we can't yet imagine. And perhaps, in the end, that's why we're drawn to it. Not because it's familiar, but because it's not. Because it challenges us. Because it's there. One day, the red planet might bloom with human habitats. Gardens growing under domes. Children born beneath a different sky. A civilization taking root where none existed before. Or perhaps Mars will remain wild, visited but not changed. A place we study and respect but leave intact. Either way, the dream endures. And as long as we look up at the night sky and see that steady red light, we'll wonder, we'll plan, we'll hope. And somewhere in that hope, Mars will continue to call to us, a world waiting across the dark. And now, with our journey to Mars complete, let the information settle softly like dust after a Martian breeze. We've traveled across a world of wonders, from towering volcanoes to ancient riverbeds, from polar ice to rust-colored plains. Mars is distant, cold, and harsh, but it's also beautiful, mysterious, and full of possibility. It's a world that once flowed with water, that might have cradled life, that could one day host humanity's greatest adventure. As you drift towards sleep, imagine standing on that red surface. Feel the lightness of your body in the lower gravity. Watch dust devils spiral in the distance. See the sun setting with its strange blue halo, and above you, in the pink sky fading to black, Earth hangs like a bright star, a reminder of home across the void. Mars is out there right now, turning slowly in the darkness, and perhaps one day, you or someone you'll never meet will stand upon it, the first to see those wonders not through a camera, but with their own eyes. Until then, rest easy. Let your thoughts drift across those alien landscapes, and know that in the vastness of space, there are worlds waiting, stories yet to be told, and dreams still coming true. Good night, traveler. And thank you for journeying with us to the Red Planet.